Hi everyone, now I'm going to show you how we solve question number 8 on homework 7. So we are given a Poisson process which is defined by the properties that the number of T1, T2 of the points Ti in the interval of T1, T2 of length T is equal to T2 minus T1 is a Poisson random variable with parameter lambda t. So P of T1, T2 is equal to K and it's equal to e to the negative lambda t times the lambda t to the k's power over k factorial. So if the intervals T1, T2, and T3, T4 are non-overlapping, then the random variables n of T1, T2, and n of T3, T4 are independent. So at a time moment t, there is no more one Poisson point. Using the points ti, we form the stochastic process. Xt is equal to n of 0 t, and the graph are given. And on part A, we are required to find e of xt. So in the textbook are given, we know for px equals to t equal to e to the negative lambda times lambda k over k factorial is, and we can take the summation and is equal to 1, so which gets the summation of 0 to x lambda k over k factorial is equal to e of lambda, and k times lambda k minus 1 over k factorial is equal to e to the lambda. And we know the summation of k times e to the negative lambda times lambda to the k's power over k factorial is equal to lambda, which will also get ex is equal to the summation of 0 to infinity k times e to the negative lambda times lambda to the k's power over k factorial equals to lambda. So the variance, and we square the variance equal to e of x minus n squared, and is equal to e of x squared minus n squared equal to e of x squared minus lambda squared. And so the summation of k to the infinity k times lambda to the k's power over k factorial is equal to lambda e to the lambda power. So based on the clues, therefore we know that e of xt is equal to lambda times t, and which gets e of x squared t is equal to 1 plus lambda t times lambda t, and the variance xt equal to lambda t. So we solved for part A. Part B, we are required to find R of T1, T2. So Pxt is smaller than or equal to K is equal to the summation of 0 to K. P of n 0t is equal to I equals to 0 to K e to the negative lambda times the data times lambda t to the i's power over I factorial. So, and also if you plug in the numbers, px2 is smaller than or equal to 3, is equal to the summation of 0 to 3 e over negative 4 over 3 times 4 over 3 to the k's power over k factorial is equal to e to the negative 3 over 4 over 3 times 1 plus 4 over 3 plus 1/2 times 4 over 3 square plus 1 over 6 times 4 over 3 to the cubic power, which is equal to 0.955.